So, before I dive in the intro, I've got to say how truly enjoyable it is to be the host and see in the background kids bobbing around, or Miss Cottrell's class come in where they're all just grooving instantly as the camera turns on. So, thank you for that to start my day. It's delightful every single time. My name is Jesse. Welcome to another exciting Exploring by the Seat of Your Pants broadcast with us here. I know we've got a lot of familiar faces in the crowd, but if you are new to us, we're all about bringing conservation, adventure, and science into classrooms around the world. Quick note too, yesterday was particularly epic. So if you guys want to check out Alejandro's amazing talk live from the Amazon rainforest, or Jordan Mallon talking about digging up dinosaur bones in Alberta, those and every other program we do are on our YouTube channel. There's so much to explore and discover there, and I really hope you take the opportunity when you're done. We got a bunch of classes live with us now. I will note today's going to be particularly interactive, so if you all want to unmute your mics, I will be coming to classes one by one for questions throughout the broadcast today before the official Q&A at the end. Now today I'm really pleased to welcome back my friend Tom Vassos. He is an astronomer extraordinaire. He gets the chance to highlight the glory of the cosmos, and so I'm going to bring up his slide too, but he's got a bit of an introduction for himself to share some of the cool stuff he's up to. But we are going to go on a really epic journey together today, and I want to say thank you all so much for being here. Tom, you're in the broadcast, man. Tell us a little bit about your stuff, and we'll dive right in.
Thanks so much. Yeah, I've been a past instructor at several universities, including the University of Toronto, and wrote a book called The Ultimate Guided Tour of the Universe. And I found my dream job. I get to be something called the astronomer in residence at places like Killarney Park, where they have a couple of big telescopes. It's a dark sky preserve, as well as this huge ship called the Anthem of the Seas, where we get to tell people all about astronomy and space exploration. So that's a bit about me. And sometimes people call me the professor. So you can call me Tom or professor. And here I am with 4 arms. Jesse, back to you.
That's pretty great.
All right.
I'll leave you to it. You got a lot to show us. Astronomy under the stars. This is fun, man.
All right, so we're going to talk about astronomy under the stars. Here's a beautiful time-lapse video of what the skies might look like if you were to stare at it long enough. This is a time-lapse video, and you can see what looks to be the Milky Way kind of floating across the sky, and a bunch of shooting stars called the Perseid meteor shower that's streaking through the sky there. And it's no wonder for thousands of years that humans on Earth thought that Earth was the center of the universe, because look, it looks like everything is rotating around Earth. But do you think those stars are all rotating around planet Earth? No, not really, because there was another really smart astrophotographer that kept his camera really still and took another time-lapse video to see what was really moving. And of course, the stars are in a fixed position in the sky, except for the shooting stars that are flying by. But it's only the Earth that's rotating, of course, that makes it look like the stars are moving across the sky. So we are going to have a fun day today, Jesse, because I am going to give all the attendees here today some superhero powers. But I'm wondering, Jesse, if you could open it up. I'm curious as to what some of their most favorite superhero powers are. Do you want to pick a group?
Ooh, absolutely. Okay. Scott Central Public School, favorite superhero power. What do you think?
What's your favorite superhero power? Say it. What's your favorite superhero?
Flying.
Excellent. Heavy duty flying there. I think you inspired them with Superman.
I think a lot of people like to fly. A lot of people like the fact that Superman can like zap things. But as an astronomer, my most favorite Superman superhero power is his X-ray vision, where he can see right through things, just like this cat here with his X-ray vision. Now, the great news is today I am going to give you guys superhero powers to see what we're going to see today. So strap in and let's go along for the ride. Now, I want to explain what this thing is called the electromagnetic spectrum, because light comes in all different kinds of forms. And guess what? Unfortunately, as humans, we only see a very tiny slice of light called visible light, which is less than 0.01% of light. But lucky, with the help of the Hubble telescope, we can see all the way from infrared to ultraviolet light. Or with the new James Webb Space Telescope, it can see much further in infrared light. And the other great news is, with all the telescopes around the world, we can actually now see wavelengths of light, radio waves and microwaves and X-rays and gamma rays, where we can see the rest of the 99.9% of the light that you can't see with your human eyes. But that is what I'm going to show you today, so you can see what the universe really looks like. Now, I want to teach you first about light pollution, because a lot of cities that many of us live in have light pollution, so we don't really see very much in the night sky. Here's a typical view. You might only see 10, 20, 30, or 40 stars. But what would it look like if you had multi-wavelength vision and you could see many different forms of light? Well, the sky might look something like this. You would even be able to differentiate between the young, hot blue stars and the old reddish stars. And that's why we're getting these great images from the James Webb Space Telescope, like this beautiful image of the cosmic cliffs in the Carina Nebula, or this gorgeous image of something called the Pillars of Creation, which are 40 trillion kilometers tall. But because the James Webb Space Telescope can look using infrared, it can look right through the clouds to see that there's actually new stars being formed right inside these clouds. Just an amazing view of the cosmos above. So I wanted to teach you about a concept in astronomy called the apparent size of objects, because everything, when you look up, has a certain size, but that depends on A, how big it is, but B, how far away it is. Now, the sky is divided up into 360 degrees, and the angle of the moon is about 1/2 degree. And as it turns out, the angle of the sun is also about 1/2 degree. Now, I want to remind you, never look straight at the sun because you'll damage your eyes. But how is that possible? Jesse, maybe you could open it up, because the moon and the sun appear to be almost exactly the same size, but the sun is 400 times bigger than the moon. How is that possible?
How is that possible? Miss Hurley's class, we'll head to you guys. How is it possible that the moon and the sun look the same, but different? What do we think? 6 sevens.
Hey, somebody want to answer? Daria.
The moon is closer to Earth and the sun is further away.
Exactly. So exactly. Great answer. So even though the sun is 400 times bigger, it's roughly 400 times further away. And that's why it appears to be, from Earth, roughly the same size in the sky. Now, we are going to be playing a game. So we're going to enter you into the gaming zone. Now, to play this game, I thought, where am I going to take you to play this game? I decided to take you to Mount Everest in Nepal. I don't know why. I just thought that would be a fun place to go to play this game. And we are going to play a game called Fact or Fake. And you guys are going to get to choose which image is the correct size, which one is the fact, and which one is the fake. Now, I'm going to show you different images, and you're going to decide. Now, I'm not going to let you vote for each of the images I show you, but at the very end, I'm going to open it up and hear what your answers are. But inside your classrooms there, you can tell your teacher and yell out what you think the answer is at your end. Jesse, you don't need to open it up just yet. But here, when you look up to the sky, there's a nebula called the Cygnus Loop Nebula. And I want you all to decide, what size would it appear to be? Is it A, taking up this whole screen, many times bigger than the moon, or B, roughly the same size as the moon, C, half the size of the moon, or D, just that little smudge inside that circle? Now, before you decide, I want to give you a hint, because a lot of people don't know how huge the universe is and how far away these things are. People don't realize it. So the moon is 1.3 light seconds away. That means it takes light 1.3 seconds to go from the moon to planet Earth. But this nebula is so far away, it takes light 1,800 years to reach us. That's 17,000 trillion kilometers away. So with that information about how far away this nebula is, decide in your class which is the correct size, A, B, C, or D. And I'm going to go through 5 of these examples, and then I'm going to tell you the answers at the end. This one is B. It's called the Rosette Nebula. And the hint on this one is it's even 3 times further away than the last one. It's 5,200 light years away. So you have to decide A, B, C, or D. And now the third example I want to give you is this beautiful image above the mountains called the Heart Nebula. And it's even further still. It's 7,500 light years away. So what do you think, A, B, C, or D? But now I'm going to jump really far away from Earth because these images I just showed you are only a few thousand light years away. Our nearest neighborhood galaxy, called the Andromeda galaxy, is actually 2.5 million light years away. That means it took light 2.5 million years to go all the way from the Andromeda galaxy to our eyes so that we could see it. So what do you think? A, B, C, or D is the correct size? And here is the final one before I reveal the answers, is this thing called Centaurus A, which is a quasar, an actively feeding black hole right in the middle of these two huge smudges. You can't see the black hole because it's way too tiny. But this black hole is on an active feeding frenzy, and it's shooting out these jets on either side. And that's what you're seeing in this image, these huge jets shooting out the north and the south end of these black holes. Now, before you decide what image is the correct size, I'm going to give you two hints on this one. One is that it is 5 times further away than the Andromeda galaxy. It's 12 million light years away. So this is really far. And then the second thing I'll mention on this image, I had to make the field of view twice as big. So you'll notice on this image, the moon is only half the size as the other 4 images. So to compare this one to the previous 4, these would all be twice as big. So now you have to decide what is the correct answer, A, B, C, or D. And I've been known, Jesse, to be a really fair professor. So I'm going to give everyone one last hint, and I'm going to give everyone a chance to change all their answers and just come up with one answer. And here's what the hint is. The hint is that at least 4 out of 5 and maybe 5 out of 5 out of all the images I just showed you have the exact same letter answer, A, B, C, or D. So, Jesse, I want to get everyone to answer now whether they think all 4 or 5 or all 5 of those answers of the images I showed you are all A, the biggest image, B, the second biggest, C, the second smallest, or D, that tiny little smudge inside that circle. Do you want them to do it in the comments?
Yeah, my computer's doing something weird and I'm trying to get people to do that. But if you're on YouTube and you want to share something in the comments, if you're in StreamYard with us, you want to share in the comments, we'd love to hear from you all. So we've got Miss E's class. They say A. Okay.
All right.
Michelle's class, Hurley, Scott Central, Mr. Search class. What do we think? I think it would be pretty, I think our sky would be pretty interesting if they were all A. It would be fascinating. We got some more private chat folks here. C or D. D definitively for Miss Hurley's class. Okay. So we got exact opposite answers. We got the biggest possible and the smallest possible, but D is our one that's been mentioned a couple times now.
Okay, yeah, when I do this in public, I tend to get about 80% of the people saying D, because look, I told you how far these things away. This object is over 100 million trillion kilometers away. So, Jesse, are you ready for the answers?
I'm ready. I'm so ready.
Okay, the answer to all of those is A, the largest image. That's right. This is how big the Cygnus Loop Nebula would look if you had this superhuman vision. This is how big the Rosette Nebula would look. This is how big the Heart Nebula would look. And how's this possible? I told you how far away these things are. Well, it's because they're huge. The Heart Nebula is 3,100 trillion kilometers across. Like, these objects are huge. Or the Andromeda galaxy is huge, 2 million trillion kilometers across. Or and the ship that I work on, Anthem of the Seas, it has this great big arm that lifts up out of the boat so you can get a good look at the stars. And you can see some people here in that thing that's getting raised up to the sky. And if you were on this ship and you had superhuman vision, this is how big the Andromeda galaxy would look compared to the full moon. And then the final one here, Centaurus A would look this big. And in this particular case, why is that? Because it's 1.8 million light years across. So now I'm going to show you a bunch of artist composite images. And I wanted to describe what an artist composite image is because, excuse me, a lot of you might think that It's something that an artist drew on a piece of paper, whatever, but it's not. It's a little misleading because an artist composite image is actually a whole composite of actual real images, real photographs, real astrophotographers capturing visible light and microwaves and X-rays and gamma rays and all different kinds of light, the other 99% of light that you and I can't see. But I assure you, these are all real images of what the universe looks like. So let's start with this beautiful view of Machu Picchu, which is a place on the top of a mountain in Peru. And I'm choosing some of these images of what the landscapes are because they have an astronomical significance. In this case, this was built thousands of years ago. And even back then, they had an observatory. They had a window with a room of the stars for stargazing, right? And not only that, but at the very top of this mountain, they carved out this huge giant stone. And guess what this stone is? This stone is actually a calendar. You're probably wondering, how can a stone be a calendar? Well, at exactly the spring and fall equinox, 2 dates of the year, this stone is a precise indicator of those dates because the sun is directly overhead and the shadow of the piece of the stone that rises straight up, the shadow completely disappears. And that way they know it's exactly March 21st. So imagine if you had to build a stone like this in your backyard to figure out what day of the year it was. Going back to our image, now we look into the sky. There's this huge smudge across the sky. First of all, there's a giant star called Zeta Ophiuchi, which is 20 times bigger than our sun. It's 8 times wider and it's 80,000 times brighter. And it's actually flying through the universe at 87,000 kilometers an hour. I guess you could say this is a real shooting star. And what is that huge smudge in front of it? Well, that huge smudge is actually something called a bow shock. So I don't know if you've ever been in a boat when the front of your boat is moving through the water. It kind of pushes the water in front of the boat even before the boat gets there. And that's what's happening here. It's a huge bow shock that's forming in front of the direction of where that star is flying through the universe. And all of these images I'm showing you as the true apparent size relative to the moon. So you can see in this image, if you had superhuman vision, this object here would be even bigger than the size of a full moon. Then we've got this beautiful image of the Toronto skyline, beautiful image of Toronto at night, which is where I'm from. And we've got these beautiful stars in the sky. Let's talk about what they are. On the left, we have something called open star clusters. These are loose conglomeration of stars. And then on the right side of this image, we have something called globular clusters where the stars are much more clumped together. So let's talk about each of these. This one here, they often have crazy names like this, M13 and M22, but the biggest globular cluster in terms of apparent size in the sky is this one here called Omega Centauri. It has over 10 million stars all clumped together. Just a beautiful sight to behold. And then we've got this thing called the Pleiades. It also has the nickname the Seven Sisters. So sometimes you might see that. And this is visible in the night sky to the naked eye. And then beside that one is something called the Beehive cluster. So you can see these open star clusters have a larger apparent size than the globular clusters, which are much more clumped together. So just a beautiful image of different star formations. Okay, we're going to play another game called Name That World. And so let's take a look at some images and see if you can guys can guess which objects some of these are. Jesse, let's start with this one. Who can tell us what this image is?
Ooh, Miss Cottrell's class. I'm going to head to you guys in Baldwinsville. What do we think? Saturn, universe.
Okay, I got 100% of people saying it's Saturn. And guess what? That is wrong. This is actually Neptune. How is that possible? Didn't you learn in school that it's Saturn that has the rings, not Neptune, right? Well, guess what? This is a James Webb Telescope image, which can see infrared light to discover that not only does Saturn have rings, but all 4 ice and gas giants in our solar system Uranus, Neptune, Jupiter, and Saturn all have rings, and this is a beautiful image of the rings around Neptune. Okay, here's another artist composite image that we created. Once again, these are all real images. In the middle of the image, you see a photograph there of the Dragon Bridge in Vietnam. And in the sky, I have a bunch of different objects in the sky. Who can tell me what the name of the category of all of those objects is? Jesse?
So I'll just note too. So in terms of category, are they planets? Are they stars? Are they something else perhaps? Let's see, Mr. Socha's class, 5 6s. What do we think? Galaxies. Hey.
That's right. You guys got that one correct. And these are the names of those galaxies, like the Triangulum and Whale and Sculptor, and the one called the Pinwheel Galaxy. And by the way, to make these composite images even more realistic, not only did we put all of these galaxies in the sky so you could compare their size, we even used advanced computer software to put the reflection of the galaxy in the water so you can actually see the reflection of the galaxies in the water there. Kind of a cool artistic effect. Okay, and not only that, but in this image, we can even see something called dwarf galaxies. These are galaxies that are really close to the Andromeda galaxy, and they are actually orbiting around the Andromeda galaxy, and that's why they're called dwarf galaxies. Okay, Jesse, who can tell me what the category of these objects is?
Ooh, this is a bit of a trickier one. Miss E's class, what do we think?
Miss E's class, someone go ahead. Nebulas.
Nebulas.
Okay, so that is a correct answer. These are all nebulas, but now I'm going to ask you another question, which is, which category of nebulas is it? There's another category underneath the overall concept called nebulas.
I'm not even sure I know that one. Miss E's class, you guys are still in if you want to try and...
Anyone? Anyone? Alex?
It's a special kind of nebula.
Cloud nebulas?
Okay, no. These nebulas are a special class called supernova explosions or supernova remnants. These are actually the explosions of stars, and this is the littered remnants of those explosions that are littered throughout the universe. And you can see here the comparison of these supernova explosion nebula sizes compared to the moon. Now, the reason I put them with a landscape in front of the war in eastern Ukraine, because it's so sad to me that when we read the news every day about the war in Ukraine, it just makes me cry because of what's going on. Wouldn't it be a much more wonderful world if we could get rid of all wars and just look up to the sky to the beauty of a different kind of explosion, which is the explosion of stars? If we could only transform our whole vision of what we focused on in society, I think we would have a much more beautiful world to live in. So let's look up to the sky and focus on that, because these are the names of those nebulas. And they try to name some of these like the Jellyfish Nebula after what it looks like. Kind of looks like a jellyfish swimming through the ocean. But some interesting facts about some of these nebulas. This number 2 here actually exploded in the year 185 AD, so about 1800 years ago, because all of a sudden, for a month or so, Chinese astronomers noticed that there was like a guest star in the sky that was never there before. And all of a sudden, it was the brightest star in the sky. It was even visible during the day. Or number 3 here, which exploded 1,000 years ago in the year 1054, where it was the brightest object in the sky, even visible during the day. And another thing I'll mention about these supernova explosions, that looking at all of these nebulas and in fact, all objects in the sky, it's like you are a time traveler looking back in time, because you're not looking at these objects the way they look now. You're looking at these objects the way they looked thousands or millions of years ago, because that's how long it took the light to go from that object to our eyes or to our telescope. So in the example of the Rice Hat Nebula in the bottom right corner there, that's not a picture of how it looks now, even though we just took that picture. This is how it looked in the year 12,000 BC. So congratulations, we're all time travelers looking back in time. Okay, Jesse, who can tell me the name of what that green fuzzy stuff is shooting across the sky there in
Green
Solista,
fuzzy
British
stuff.
Columbia?
Scott Central Public School, what do we think of the green fuzzy stuff?
Do we think we know what that is?
Okay, I knew you were all going to say Northern Lights, but this is another trick question. You guys should learn now. I only ask trick questions, okay? This is not the Northern Lights. This is a new phenomenon called Steve, okay? So scientists gave it the nickname Steve. These green fuzzy cloud looking things are even higher in the atmosphere, way up in the ionosphere and magnetosphere, even higher than where we see the Northern Lights. So here's a new phenomenon that you've just learned about today called Steve. And you know what? Scientists don't even know what causes these things to form. So I'm hoping when all of the students in the classes listening to things, when you guys all grow up and get into university and do research and stuff, you can help us figure out what actually causes Steve to form high up in Earth's atmosphere. For comparison purposes, here's another couple of nebulas, even larger, the North American Nebula and the Pelican Nebula. Look at that. It kind of looks like a pelican, and the North American Nebula kind of looks like North America. You can see a little bit of Mexico and Florida there. Moving on to a couple of other nebulas in the sky, even larger, above Stonehenge in England. And the reason why I chose this image was Stonehenge was also built with a lot of alignment. So it's like a calendar telling us when certain dates are occurring. It's amazing that the ancients thousands of years ago knew how to align these things. They knew so much about the stars. It's just amazing. And these larger nebulas are called the Carina Nebula and the Lagoon Nebula. Moving on to an even larger one above the Bonneville Salt Flats in Utah. And this one is called the Elephant Trunk Nebula because it's kind of got something that kind of looks like an elephant trunk right there. All right. And you can see the Milky Way galaxy on the right there, but huge nebula. Okay, now I'm going to give you some more superhero powers. Imagine if you could see radio waves. What would the cosmos look like? So let's start with this beautiful image here above Manarola, Italy. This is of the Mediterranean Sea. You see the moon in the sky, you see the Milky Way galaxy in the sky, but you kind of see that strange white smudge there with a couple of huge red things on either side of it. So if you had superhuman vision, this is what you would see. And guess what this thing is? This thing is a collision of thousands and thousands of galaxies, which is that huge white smudge in the middle, creating huge shock waves. And the shock waves are those two big red things on the right and the left side there. You are actually witnessing this huge collision of thousands of galaxies, and we can actually see the shock waves that were formed as a result of this huge collision in the sky. Isn't that beautiful? Okay, moving on to the Rocky Mountains in Colorado. This is just a visible light image of the Milky Way galaxy. So you might look up to the sky. And if you're in a dark sky preserve with not many lights around and you're not in a city, you will see a lot more stars. The Milky Way will look much more like this rather than just the 20 or 30 stars that we get to see when we live in cities. But what would this image look like if you had superhuman radio wave powers? Well, guess what? Bang, the Milky Way galaxy would look like this instead, with these huge red and yellow smudges spread throughout the sky. So this is looking towards the center of the Milky Way galaxy. Jesse, does anyone want to guess what that big yellow smudge is in the middle of the Milky Way galaxy there?
Let's see, Miss Cottrell's class. Big yellow smudge. What do we think?
No, it's not stars. What else might it be? Yes, that is very correct. Congratulations. That is the supermassive black hole called Sagittarius A Star at the center of the Milky Way galaxy. And using a radio wave telescope, we can actually see where it is. Just a fantastic image. There's other discoveries in this image as well, though. These huge red circles are also supernova explosion remnants. And then there's a whole bunch of these crazy, mysterious radio emitting magnetized threads, arcs, and ripples that are also in this radio wave picture. And once again, scientists don't even know what's causing these ripples. So once again, everyone in the classrooms here, I'm hoping when you guys grow up, you can help us figure out what these things are and what causes them. Okay, now the rest of the images I'm going to show you are so huge they won't even fit on the screen. So I'm going to double the field of view. I'm going to make the moon half as big as it was for the previous images. And let's take a look at some other huge objects that we would see in the sky. This huge smudge is one of our closest dwarf galaxies called the Large Magellanic Cloud. And it's called a dwarf galaxy because it's orbiting around the Milky Way galaxy. And you won't get a chance to see this in the northern hemisphere. It's mostly visible from the southern hemisphere. So if you're ever visiting somewhere south, you might get a chance to see this smudge in the sky, which is visible even to the naked eye. It just wouldn't look quite this big and beautiful. And also looking above the skies in New Taipei City, Taiwan, is the Small Magellanic Cloud, another dwarf galaxy that's orbiting the Milky Way galaxy. Okay, let's move on to this crazy image above the Eiffel Tower in Paris, France. In the middle there, we've got another nebula called the Orion Nebula. But what is that huge red thing? Look how big it is compared to the moon. Guess what? That huge red semicircle you see there called Bernard's Loop is actually the remnant of a huge supernova explosion tens of thousands of years or even millions of years ago. Look how big that would appear in the sky. Okay, now imagine if you could see X-rays. So this is kind of seeing X-rays, just the way if you ever go into the hospital, if you broke a bone or something, that they use an X-ray imaging to look right through your skin to see what your bones look like. What if we turned our X-ray vision to the sky? Well, guess what? We would see this huge supernova explosion called the Vela supernova remnant. What if we could see X-rays and radio waves at the same time? What would the cosmos look like? Well, this is what it would look like above something called El Castillo in Chichen Itza, Mexico. You would actually look up to the sky and you would see a whole clustering of galaxies called the Virgo Cluster. And look at that. Each one of these individual galaxy appears roughly the same size of the moon. Wouldn't that be an amazing sight to see with your superhuman vision looking up to the sky? And Jesse, the reason I chose this image on this one is Chichen Itza also has very specific astronomical alignments. Even though it was built hundreds and hundreds of years ago, it's perfectly aligned north, south, east, west. It has exactly 365 steps, the exact number of days in the year. And it has something called the return of the sun serpent at exactly a certain equinox or solstice at a certain date of the year. There's a shadow that appears going up the stairs. It almost looks like a serpent. They call it a sun serpent. And when they see that shadow of the serpent going up the stairs, that actually marks a certain calendar day of the year. So you could kind of say this building is like a calendar to tell you what day of the year is. Just amazing. Okay, the rest of the images are even bigger. We're going to have to quadruple our field of view and make the moon 1/4 the size. And you can see the tiny moon in the bottom right corner here and a beautiful image of Comet McNaught. You can't see Comet McNaught because it's way too tiny, but you can see its tail, which is as long as about 70 full moons lined up from end to end. This beautiful image of Comet McNaught that was taken above the Pacific Ocean. Okay, if you could see radio waves again, but for this one, we have to make our field of view 6 times as big and the moon 1/6 the size. So you can see the tiny moon in the top left corner. And on the right side of this image, of course, you see the Milky Way galaxy. But what would this image look like with your superhuman radio wave vision you would actually see this huge cloud, which is called Smith's cloud, named after the person that discovered it by the name of Smith. So guess what? If you guys discover stuff like this in the future, we're going to name stuff like this after you. So see if you can do that when you're growing up. Smith's cloud. So Smith's cloud is actually on a collision course with the Milky Way galaxy. You can see it heading right in the direction of the Milky Way galaxy. It's going to hit the Milky Way galaxy in about 30 million years. And when it does, it's going to cause a flurry of new star creation. So it's going to birth possibly thousands of new stars, because the dust in Smith's cloud is going to combine with the dust in the Milky Way cloud, Milky Way galaxy. And that combination of dust is going to cause a flurry of new star formation. So look forward to that in about 30 million years from now. Okay, how about this beautiful image above Mount Everest, Nepal? A beautiful view of the starry sky above. But guess what? This is actually not a beautiful view of the starry sky, Jesse, because this is actually an image of almost 25,000 active supermassive black holes. This is actually a picture of thousands of active supermassive black holes in the sky. This is what you would see if you had radio wave vision like Superman and could see up to the sky. You wouldn't have to see just stars. You could look up to the sky and see all of these supermassive black holes. Wouldn't that be a sight to see? I want to mention a couple of things about the actual observatory that took this picture, because you probably have a picture of what a telescope looks like. It's got a lens and things like that, and you look through an eyepiece and you look up to the sky. Well, today's telescopes look a lot different. This is this radio wave observatory. It actually has 52 stations with 20,000 antennas. So you're not looking through an eyepiece, but it's something called an interferometer. It actually combines the data from all 20,000 of those images to actually create the image that I just showed you. So that's kind of cool. In fact, these antennas are actually spread across 9 different countries throughout Europe. And once they actually complete the sky survey that they're completing, they've found 25,000 supermassive active black holes with only surveying 4% of the sky. So once they survey the entire sky, they're going to find like over 1 million supermassive black holes out there. Just amazing. Okay, imagine if you could see gamma rays. Let's start with just a visible light image of the Great Sand Dunes National Park. If you looked up here with a long exposure image, you would see this beautiful image of the Milky Way galaxy. This is probably one of my most favorite images of the Milky Way galaxy. So this is a visible light image, but it's a long exposure image. But you would actually see something pretty nice if you were at a dark sky area like this looking up to the sky. But what would it look like if you had superhuman gamma ray vision? The Milky Way galaxy would look like this. So what is this? This is 2 huge jets shooting out from the center of the Milky Way galaxy. They've been given the name the Fermi bubbles. And scientists believe they have discovered, now that they have the picture of what these bubbles look like, they believe they know what caused these bubbles. And at the very center of where those 2 lobes are, right about here, is Sagittarius A Star, the supermassive black hole at the center of the Milky Way galaxy. And what scientists believe happened is that it went on a feeding frenzy millions of years ago and shot out, it's kind of like 2 burps, you know, on the north end of the black hole and the south end of the black hole, 2 huge burps of dust and debris and materials and all kinds of things shooting out both ends of the black hole. And now, millions of years later, we are viewing what these actual lobes look like, but only if you have superhuman gamma ray vision. What about if we could see what an advanced supercomputer would see? While looking above the deck of the Anthem of the Seas, you would look up to the sky and see this intricate network of thousands and thousands of galaxies called the cosmic web. The brighter parts is where tens of thousands of galaxies are already clumped together, and the filaments in between the galaxies is where thousands of galaxies are headed toward the central part of those areas. So this stream here of galaxies is heading in this direction to join up with these here. And out of all the images I showed you today, this is the only one that's not a real image. It's just a computer simulated image, but that is what you'd look like according to some advanced supercomputers if you were to look up to the sky. What about if you could see microwaves, our very last superhuman power, Jesse, before we...
Yes, okay. I just our classes do need to go pretty soon, so this will have to be the last one.
Yeah. Last one is if you could see microwave vision above Jasper, Alberta, you would see this thing called the cosmic microwave background. And this is actually a microwave image of the actual explosion of the Big Bang that scientists have actually been able to take. This is actually a picture of the remnants of the Big Bang explosion that happened 13.8 billion years ago. And often people ask me, which direction is this image in? It's not in any direction, or it's in every direction. You have to picture yourself being in the middle of this globe and looking out in all directions. You would see the cosmic microwave background in all directions, no matter whether you're looking up the sky in Switzerland or whether you're in Malaysia looking up to the sky, you would see the cosmic microwave background, or above the skies in Hong Kong, or this final image here above the skies in Moraine Lake, Banff, Alberta, where you would look up to the skies and see the cosmic microwave background. So in closing, I want to say this great quote from Marcel Proust that says, "The real voyage of discovery consists not in seeking new landscapes, but in having new eyes." So I hope you agree that I have given you new eyes today to see the universe in a whole new way. And with that, Jesse, I'll turn it back to you. Thank you so much.
Thank you so much, Tom. And I will note, if any of our classes do have to go, Tom is like the most responsive guy you will ever have, ever. And the cosmologistwithoutborders.org, if you want to reach out to him there. We also have his email, of course, if you want to get in touch and ask any additional questions after the broadcast is done. But Tom, if you want to exit screen share so you can see us again, have a bit of a conversation, we'll try and take one question per class before people need to head off. Miss E's group, Waterloo, if you guys want to kick us off, room 14, with any question you'd like about space, anything you learned today, you're in and go for it. Hi. Hey. Hey, Alex. Hi.
What is the difference between black holes and white holes?
Great question. What's the difference between black holes and white holes? Okay, so here's the thing. We know that black holes exist. You've seen pictures that I've showed you. We've actually taken pictures of black holes like the Sagittarius A Star, the one at the center of the Milky Way galaxy. But beyond the event horizon, we don't really know what's going on inside a black hole, because light can't come out to show us what's happening right inside the black hole. But scientists have a couple of different theories. One of those theories is that at the very center of the black hole is something called a wormhole, which is like a tunnel to the opposite side of the universe. And all of the stuff that falls into the black hole at our end will shoot out something called a white hole at the far end of the universe. But I will have to mention something about white holes is, although they are theoretically possible, we have never found one. We don't have evidence of one. We haven't taken pictures of one. We don't really know even if they exist. Yep. But there is some scientific evidence, at least on paper, that says they might exist. So we're searching through the cosmos to see if we can find one.
Fantastic. Good question to kick us off, folks. Miss Cottrell's class, if you guys need to go, great. I'll say farewell. Miss Hurley's class, if you guys want a question, come on in. 6'7". Hi.
Can you see the light pollution that comes off Earth from space?
Okay, good question. Can you see the light pollution That comes off Earth from space. Yes, absolutely. If you search on Google and look for images that the scientists have taken, when they take images back of Earth at night, literally you can see all of the cities, huge bright lights interconnected, and the megalopolises with all of the lights on. But of course, they still get a beautiful view of Earth when they take those pictures. So take a look at those. But when they start taking photographs looking out towards the sky, the light from Earth doesn't hamper them. So they get really beautiful pictures of the stars as they are looking out the windows from the International Space Station versus the view that we get.
Yeah, it's one of the reasons we send these telescopes up into space is to sort of mitigate these effects that we'd have on Earth with land-based telescopes. And so that's why we get such incredible images from something like the James Webb Space Telescope, which I will note, web.nasa.gov, some of the most amazing images, scientific stories you'll ever see if you want to check out their website there. Some really, really cool stuff. We'll take 2 more questions, Tom. Scott Central Public School, if you guys have one more for us, come on.
We don't have a question, but we did want to say goodbye and thank you.
Thank you so much, guys. So nice to have you on.
Thanks, guys.
Well, we'll take one from our YouTube friends then. Ms. Ferguson's class wants to know, how do you take pictures of the nebula? Like, well, how do you, doing this, what device, what's going on?
Okay, good question. How do you take pictures of nebulas? So 2 different ways primarily. One is from Earth-based telescopes, so just looking up to the sky and doing a long exposure image. So not just like a quick 1-second snap, but staring at that nebula for 20, 30, 40, 50 seconds. The longer you can stare at the nebula, the sharper the image you'll get because you're collecting more photons of light. Also, Earth-based telescopes, like at the top of mountains in Peru and Hawaii and things like that, they stare at these nebulas for literally not just minutes, but potentially a lot longer than that. So they can get really crisp images. But then the final way we get even crisper images is taking images from space-based telescopes like Hubble and James Webb Telescope, where we don't have that light pollution to contend with.
Fantastic. Tom, I know we can do questions all day. I know our classes do need to go in a minute, so I will just note again, if you want to check out Cosmologists Without Borders, if you want to check out Tom's TEDx talk, I'll put this in the StreamYard chat for everybody in just a second as well. Learn even more about the cosmos, one of our favorite people we have bringing you on. And of course, Tom's done several programs with us. So if you head to our YouTube channel, type in his name, you'll see even more stories from across the universe. Tom, is there any last message you want to share with us before I bring back our classes to say thanks and farewell?
I would just like to say, look up to the stars more. Too often in the city, we forget that there's the skies above, especially most recently, both Jupiter and Venus are very visible in the sky. So when you go out and look at the first couple of stars that you see in the night sky, don't wish on them because they're probably not stars. They're probably Jupiter and Venus. So spend more time gazing up to the skies.
Outstanding. Hard to beat a better message than that for an astronomy talk. So Ms. Hurley's class will say farewell to you guys. Have a wonderful day, everyone. Bye for now. Everyone else, thank you so